You're listening to the STEMxm podcast, highlighting women in the fields of science, technology, engineering, and mathematics. And now, your host, Mel the Engineer.
Hello and welcome to the show. Here on STEMxm, my goal is to bring you inspiring stories on careers in science, technology, engineering, and mathematics. Today we've got an amazing plastics engineer with us, Miss Lynzie Nebel. I want to take a moment to give a huge thanks to Lynzie right now for two reasons. She's connected me with lots of other amazing women in STEM to interview, so thank you for that. And she actually let me redo the interview with her because I bollocksed the sound the first time we tried to get through it. So thanks again, Lynzie. Okay, so let's get into it and learn from Lynzie Nebel what the plastics engineering field is all about. Hello and welcome to STEMxm. Today we have Lynzie Nebel. Am I pronouncing that right?
Yep, it's Rebel with an N.
That's awesome. Lynzie Nebel with us, and she is a plastics engineer. So tell us, Lynzie, about plastics engineering and talk to us a little bit about how it overlaps with materials engineering or how it doesn't overlap with materials engineering.
All right. So one of the biggest things I always hear whenever I tell anyone I'm a plastics engineer, they always assume, oh, so you work with the actual chemistry of materials. And that's not what a plastics engineer undergraduate degree focuses on for the most part. Now, what we focus on is a lot of how you build parts with the plastic. So we focus on the manufacturing of parts. We focus on the design of the parts. And that's where a big chunk of all the schools teaching plastics engineering focus on, especially with injection molding, because injection molding tends to be the most common process to make parts out of plastics, because while it's kind of an expensive upfront type thing, it can mold repeatable parts for millions and millions of cycles, and it just makes it a lot easier on everyone else. So that's really what plastics engineers kind of start out studying.
Okay, and for people who haven't seen this actual equipment, can you describe for us a little bit about the injection molding and extrusion processes?
Yes, so injection molding is basically you build this steel mold that will create, it basically creates it's like a plaster of Paris mold that you would make. So you're basically creating something that the material is going to be forced into, and it makes that shape. It forces it to create this shape that you're going to be making. It's probably a pretty rudimentary description, and I probably have a lot of people rolling their eyes at me, but that's kind of the way I think about it. And you use this press that basically it'll melt the material, it'll push the material into this mold cavity, and then there's a clamp force that holds it shut, and then when it's cooled and the part's formed, it opens up the mold, drops the part, and then you have your injection molded part. And there's variations on that, obviously. And extrusion molding is really basically with your pipes, stuff like that. You're basically just taking melted material and you're forcing it through what they call a die. And that basically gives it the shape, the profile that's going to be extruded. And I know I'm not as familiar with extrusion, but in my experience, they put it through a wet bath as it was being molded to basically cool it down as it's going through. And that's how that pipe was made in particular. So pretty, that's again, simplistic overview of that. There's blow molding where you can create, basically sometimes you'll injection mold preforms, like with plastic pop bottles. They make what kind of looks like a test tube. So you have the part where the cap screws on, and then it kind of has this just test tubey bottom to it. And that part's injection molded, and then they put it in another press. They kind of remelt that test tube part and inject air into it, and that blows it up to the outside of the cavities. You have rotational molding where you basically just take a plastic material mix and you close it up and the thing basically is like a giant dryer, just kind of tumbles and moves around and forces all the material to the outside of the mold, and it creates like a hollow part without having to inject air into it. So you can kind of have more seamless parts.
Yeah, I think that's really funny. You said test tube, and I think I've seen those little things before, like in the bottle manufacturing process, where they just like inflate them all almost. So maybe we could find a good picture of that, and I'll put it in the show notes. That's a pretty good description of it. So talk to us about how you got into plastics engineering and how you made that decision and what school you ended up at.
So my story probably isn't as traditional as most engineers. I liked Legos; those were cool. But I was never someone who thought of themselves as like a mechanically inclined person. I wasn't, I was your stereotypical Midwestern girl, and I did love Barbies, big fan of Barbies. And basically when I was in school, high school, I was a pretty decent musician, viola, in case anyone's wondering. It's the unsung hero of the orchestra. And I was also a cheerleader. And it just happened at one of our games, our halftime performance. I basically ended up tearing some ligaments in my wrist, and that kind of shut down my music career because I couldn't play as long. I mean, I'm much better now, but even still, musicians tend to have to play a lot longer than I can play for. So I was taking some classes in the technology wing at high school, and they happened to have this little tabletop injection molding press, and I just thought, wow, that's really cool. And I ended up just kind of doing some research, and I found Penn State Behrend in Erie, PA, which is where I ended up. And I just fell in love with the industry.
That's really awesome. So you went to school in Pennsylvania, and as you started to go through these courses, what made you see, or how could you tell that it was really a good fit for you?
So obviously I had some hesitation, given the fact that I had no prior engineering experience. Some of the guys had done CAD classes in school. Some of them, really enjoyed math and science. And don't get me wrong, those are critical things to know, but I wasn't, a rock star. I couldn't, do calculus in my sleep. I just was an average student who did all right at these things. But what really kind of made the program for me is a couple of things. One, just a very tight-knit community. I'm still very close with some of my old professors. I'm still very close with the guys I graduated with. And so, that helped. When you're learning plastics, it's this thing that nobody really knows about. So there's not really anyone who has an advantage going into it. So it's kind of nice to all start at one level. And then the program has a really great amount of hands-on labs. So we would set presses, set up water lines, take molds out, take molds apart. Just this simple day-to-day stuff that you normally wouldn't think of when you're trying to, get a college degree, but it's so fundamental. And basically we would learn how to do these basics, and then you back it out and you're like, okay, well, when you're setting the water lines, if you're running this material, you need this mold temperature, and it starts to piece together because you basically learn all the reasons why after you learn the how.
Yeah, that's really amazing. And I think the hands-on aspect to it is really great. And I think that expedites the learning to do something that's not just theoretical, for sure.
Oh, yeah, definitely.
So you mentioned before that you knew, you looked up a little bit about the universities that offer this program. And of course, plastics is highly specialized, so it's not something offered at every university. Can you talk to us about where students might be able to pursue this?
Yeah, so that's one of the, I don't know if it's a benefit or kind of a bummer, because the plastics industry is so huge, and there are so few schools that actually offer a plastics engineering degree. I mean, it's great for the students because you graduate and you have all these job offers. I mean, even as a professional adult here, and I'm looking for interns, I try and hire them early in the fall for that following summer because there's just so many offers and not enough students. So, but there are currently 6 ABET accredited plastics engineering schools. So there's Penn State Behrend, which is part of the Penn State campus, but this is the Erie branch, and it's a gorgeous school, I will say. Just it's situated in Erie, PA, and it has a gorge that goes back to it, and it's on all this property. Very biased, kind of loved it there. But there's that school. There's the Pennsylvania College of Technology in Williamsport, PA, which is, I believe it's still kind of under the Penn State branch, but it's more of, well, obviously it's a technology college. So I don't know the legalities of that, but they are technically the same Penn State branch or Penn State umbrella. But I know they focus a little bit more on like thermoforming, and I believe some of the other plastics processes more so than Penn State does. Penn State Behrend focuses a lot more on injection molding. There's Pittsburgh, Kansas, which I just was not really willing to go to a school with the gorillas as their mascot. I mean, maybe for someone else, but I just wasn't feeling it. Then there's also UMass Lowell, which is up here in Lowell, Massachusetts, and that's one of the other major plastic schools. It's usually UMass Lowell and Penn State Behrend are kind of the 2 big schools because they're the longest ABET accredited schools is really the reason why most people know of those. And then there's University of Wisconsin, Stout. They have an ABET accredited school. There's actually one on the West Coast, and which is kind of silly considering how many plastics companies are on the West Coast. There's only one school. And it's Western Washington University. And then I believe Ferris State University is working on their accreditation. I know they have a plastics program, and I've met a couple guys through their program. So I know they're doing plastic stuff. I just don't know that they're not ABET accredited at this point.
Okay. Great. So there's several options across the country, but it's just not everywhere.
Right.
And you said that your class was quite small. Could you talk to us about your experience in being in a small program and what that was like?
Yeah. So we graduated, I believe, 34 people in my class, 4 of which were women. So obviously we were severely outnumbered, but I have heard that the recent classes have like a class of about 40, and I think they have like 17 women. So it really is turning around. But the small classes it's everything because, like I said, we were always in study groups together. I still refer to all my professors if I have like a question. I just shoot them if I see anything weird, it's like, hey, what's your experience on this? And usually I get a response from one of them within, an hour or 2. And I know a lot of programs don't have that. And the plastics industry itself is very tightly knit. So it's any job I've had, anytime I've, needed assistance outside of that, I can refer back to my the guys I graduated with, my professors, and even we do a lot of alumni adventures. and we have a golf outing for plastics alumni every 2 years. And we, all connect there, and we just still stay in contact. I don't know. It's very weird for me when I meet someone in the industry and we don't have a mutual acquaintance.
Yeah, that's pretty cool. That does sound really tight-knit. So,
yeah, it's great.
Have you thought about going back for a master's degree, and do you think that is important in some way to career progression in this field? And if it's not like a master's degree in plastics engineering, is there some other type of degree that would be useful to you on this career path?
Yeah, so in my class, I think on average, probably about a third of the students go straight to grad school. Some of them choose like a mechanical engineering master's. Some of them that go to UMass Lowell and get their plastics engineering master's. Penn State does not currently offer a master's. At Behrend, there's a mechanical engineering program that you can go to the main campus, I believe. But honestly, with my experience, I haven't really needed a plastics engineering master's degree right now. If I did decide to get one, it would probably be more of an MBA or something along those lines, master's in manufacturing, something like that. And the other thing that a lot of guys do is they'll go to a polymer school. So they go to Southern Miss. I think we have guys at Case Western. I think those are the two big schools that usually take polymer type classes. And at that point, they go more into the material science and the chemistry behind plastics.
Very cool. So talk to us about what you have enjoyed most about your line of work.
Yeah, so I really love being in this industry. I try and sign up for everything, join everything, be at all the meetings. That's kind of my thing. And I always go back to this all the time, but I really love the industry's, tightness. I love being involved and knowing a lot of these people and, seeing how we can all kind of benefit each other. But another cool thing about my job specifically that I'm at MTD Micromolding in Charlton, Massachusetts right now, and we do 100% micromolding and 100% medical molding. We don't do anything outside of that. So what we do are a lot of implantable devices, a lot of life-saving devices, a lot of things that are just kind of revolutionary in my mind. And I'm not a medical person, so maybe I'm just seeing this naively, but these projects are just things that, 5 years ago, you maybe couldn't have put something into someone's body and then have it dissolve so that way they don't have to get a second surgery. That's a huge deal, especially, the older you are, the more at risk you are when you have these surgeries, and to only have to do one, it's just so cool to me that I'm helping do this on a level without having to be a medical professional.
That is really amazing. It sounds really gratifying. So for our listeners who would not be familiar with this process, could you talk to us about maybe one, I don't want to say piece of equipment, but one thing that your company would make from concept to manufacture? What happens? Like who's doing the design, and what happens when it comes to your company and it's time to produce it? What are the steps that happen through all this?
Okay. So what we do is we are what is called a custom injection molding company. So that means that we don't do any of our own design. We don't make anything that we would sell under like an MTD brand or anything like that. We work with the top medical companies, and they're usually called OEMs. And they basically provide their designs to us, and they have to do all the product part development. So, for example, we have this part that's a staple. It's a bioabsorbable staple, and basically the customer themselves, they're responsible for, any patents, any biocompatibility testing, which is basically, verifying that the material they're using doesn't have any crazy reactions with humans at all. And they're responsible for the part functionality and all that. What we do is we take that part design, and we're responsible for making sure that we can build one of those steel molds that can mold this part to their tolerances, repeatable, and it, needs to be defect free. There are some defects that can happen in injection molding, especially if your mold is not built right, or if you're running the material the way it wasn't intended to be run. So, you do have to be conscientious of that kind of stuff, and you have to be incredibly conscientious of that stuff when you're doing it at a micro level and a medical level. So our parts are basically, we'll get the parts, part design, we'll design the mold. We build the molds in-house. There's a lot of responsibility in this steel, obviously. So we like to keep it in-house. That way we have, our eyes on it at all times. Then we have some of the best processing guys I've, ever dealt with. And they're responsible for basically putting that mold in the press, making sure, it seems so trivial, but make sure it opens and shuts and pushes the part out of the mold is key. It's such a simple concept, but if your mold isn't doing that and you're running these parts every 14 seconds and something stays open a little bit longer than it should, you can set the whole thing off, because you have robots that'll come in and interact, and they take the parts and they present them to a camera so that we can verify there's no crazy defects. And so there's a lot that goes just into that part alone. We basically have to make sure we're able to measure that part repeatably. So we do a gauge R&R, which is a gauge repeatability and reproducibility study, which basically makes sure that it doesn't matter who's measuring the part, but the part itself, the dimensions we're getting off that are true.
Okay, I have a couple
Sure.
questions about that. So the people that you mentioned who would be working on the molds and adjusting these parts to make sure that as it goes through the manufacture process that it's really accurate or precise. Mm-hmm. Who are those people? Are they technicians of some sort?
So our tooling guys, there are a lot of, tooling technicians. A lot of them have years and years of experience in the industry. They know how to run, some of these CNC machines, electrode machines. They're very good at these steel manipulation equipment.
What's a CNC machine?
A CNC machine is basically, how to describe this? It's basically like a automated mill, I guess. So basically we build a program, and then what it does is it'll take the steel and it cuts it down to where the part needs to be.
Okay.
Description.
So is that something that is like trimming it afterwards?
No, that's so we would use the CNC machine to build like our tool frames, the cavity core blocks, some of the bigger picture items on a mold.
Okay. Gotcha. And then you mentioned a term, tolerance. Some of our listeners might not know what that is. Can you briefly explain tolerance?
Yeah. So when a customer decides what they want their part functionality to be, how they want it to fit against other parts, they need to take into account that you're not ever going to make anything perfect. That's just the way the world works. And so you have to give some level of, it's hard not to use the word tolerance, but you have to give some level of dimensional exception to what you want the part to be. So you have to say, you want your part to be an inch, which is crazy big in the micro world. But say you wanted it to be an inch. You can say, okay, well, this part interacts with this gasket. So that's a seal. We want it to be a little bit tighter. We want it to be 0.2 inches. 0.2 inches more or 0.2 inches less is the most you can go. And that way, as long as we build the part within that,
range?
Within that range, then we are making a part to spec.
Okay. Very cool. Thanks for explaining that. Actually,
sorry.
No, that's really good. So, this is the kind of stuff we want to make sure we, cover and explain. You actually just mentioned another term that I think is good to explain. You said spec, which is short for specification. With respect to your work, can you just briefly describe what a specification is?
Sure. When we get a drawing from a customer, we consider that basically our spec. It's our communication tool from the customer to us. So anything on there that they need us to be doing every time needs to be on that drawing. Now, sometimes, in bigger companies, they'll have them refer to outside specs, which will sometimes include things like, packaging or documentation you need. But for the most part, our specs include the dimensions that we need to make, the tolerances, the material, and once in a while, there'll be a functionality test if they need us to do something in-house. It's kind of rare just because that is a second step, and that's not really where, we can do it, but we don't have that type of equipment set up en masse like some other companies do.
Okay, great. Thank you. I want to talk a little bit about some more general career ideas, but before we go into that, is there anything else about the technical side of being a plastics engineer that you would want to share with young people or students who are thinking about going into plastics engineering?
I guess the one thing I would say is just, plastics is a very underrated industry. I still have people telling me all the time, oh, plastics engineering, I didn't know you could do that. And just, take a second and look around you, and you can easily find almost everything you have is made of plastics. And I think also a lot of people think, well, you got to really like chemistry, or you really have to be, mechanically inclined. You don't have to be any of those things. You just have to be willing to learn, willing to understand this field. And it's a lot, it seems more intimidating than it really is. It's a great group to be a part of, and you're doing so many amazing, there's so many amazing job opportunities. There's so many amazing different aspects of the industry. I know they're always looking for people who are a little bit more artistic. I know if you think you're artistic, you might think, oh, well, engineering's not for me. Well, we need part designers. If you have a great eye for that natural design of stuff, well, if you know how to do that and you know the how to create a part that could be molded, that's a huge gap that sometimes, needs to be filled. So I would just say always keep an open mind when it comes to plastics. It's a lot more surprising than you think.
Very cool. And that segues well for us. is there a plastics engineering specific organization or organizations that students could look at?
Yes, I would definitely encourage anyone who's interested in the plastics industry. So there's the Society of Plastics Engineers, which is at 4spe.org, because the petroleum engineers did take the spe.org. So we're left with the 4SPE. But that site has a huge wealth of knowledge. A student membership's very inexpensive. I think it's like $30. And that gets you basically access to the entire community. You have access to any paper that's been presented at like a conference or anything like that, which those go back, I think they started saving them since the 80s, I want to say. So, but even that alone, that's a huge amount of technical papers that you can access. You have discounted registration to any conference that you want to go to. You have a membership directory. So if you need to talk to someone at a different company and they're an SPE member, I mean, that's so easy to just go look up. And then I've also co-founded a nonprofit called Advocates for Plastics Careers with another woman who works at a company based in California. And basically what APC, as we're calling it, is a location for anyone who is interested in the industry, especially, students, their parents, and we have kind of a subset focus on military veterans and women, because those are two groups that sometimes tend to not necessarily think about plastics when they're choosing a college degree, and they really should. I can go on and on about the lists why military veterans and women should be involved in plastic. And that website's called moldingthefuture.org. And it's in the works. So we are adding content as we go. But that's going to be a really great just resource for anyone who's at all thinking about plastics.
Okay, and we're recording this in mid-2016, so if you're listening to this in the future, that site may be running full. So we'll put the Society of Plastics Engineers and the Advocates for Plastics Careers web pages in our show notes so that people can go and access them. So thanks.
Awesome.
Yeah, thanks for sharing that. That's really great. Those are going to be really good resources. So thinking more about just the career in general, is there anything that you've seen another engineer do, or maybe that you look back on your career and you've done yourself that really helped your career accelerate or put it in the right direction?
So I think kind of what I should have done a while ago is just kind of stop underestimating myself. Going into the program, obviously not in a completely traditional way, I kind of thought, well, I might be able to do this. And then you get there and you realize, you're just as smart as everyone else. Nobody has the leg up. I mean, yeah, occasionally the super, super smart people, but whatever, they exist. And, once you kind of get that confidence in yourself and you realize, okay, I'm just as good at this, it really does open up a lot of doors. I know that held me back on maybe a couple interviews. Not that I would still get the offers, but I would kind of think, well, I'm not really cut out to do that. Maybe I won't do that. And I think a lot of times, especially as women, and I don't mean to paint broad strokes here, but at least in my experience in talking, with other women women engineers is, we tend to kind of go, well, this isn't the perfect job for me, so maybe I'll just hang out. And I don't know that that's necessarily how a lot of men operate. I think a lot of men just kind of go, yeah, I'll figure it out. And once you kind of just take that attitude of, yeah, I'll figure it out, you find that you do figure it out. Or you already even knew it. You're just kind of, underestimated yourself. So
absolutely. I think, you've probably seen some of the recent research that has shown that men are more likely to apply for jobs that on paper, according to what the job description says, they're underqualified. And women would look at the same thing and have the same qualifications and think to themselves, well, I don't meet every single criteria here, so I'm not going to apply for it. I think it's a kind of similar thing. And
yeah.
I would agree with you. I had a similar experience in school where, looking back on it, there's very few people who are just naturally inclined to do differential equations and master it,
right.
On day one. That's a tiny minority. I'd be shocked if it were even 1%. So, yeah, I think that women do need to have that confidence, and sometimes you have to fake it. So if there were some young women listening to this and they're thinking about an engineering career, what's the one takeaway you would want them to get?
I would say, this again, probably pretty simple, but just do it. You'll be fine. It's not an intimidating industry. It sets itself up to be, and I think that's what has prevented so many women from, going into these degrees. But I think if you talk to any female engineer, you'll find it's not as much of a boys club in the sense that, they're trying to kick you out of there. I think it's just a boys club just because there's not any women there.
That's good advice. So are there any other things that you want to tell us about getting involved with an organization like SPE or Society of Women Engineers?
Again, I keep harping on it, but networking is the biggest single game changer in industry. Especially in the plastics industry. Again, I can't really talk to the other industries, but I do have I know obviously outside the plastics industry, and I've heard that it's not quite the same. We're very close. So if you're attending these conferences or these shows, or going to these alumni get-togethers or anything along those lines, you are going to make so many connections that just change the way you can do work. Like I said earlier, I can easily contact any of my old professors for a quick question or a quick, hey, have you seen this? I have met many different guys through some of these other outings and conferences, and their companies range from the big ones, John Deere, Microsoft, Apple, to some of the big material suppliers like PolyOne, colorant companies like Clariant, a lot of guys that do specialized things. Actually, one of the guys I graduated with, he works at NASA. So, just a huge spectrum of where people end up. And, now I have those connections to talk to anyone. And it's all because I stay connected. I stay in these industry groups like SPE and SWE. And it's a great tool that I think people assume, I can just go on LinkedIn or I can go on Facebook. It is not the same.
Yeah, I totally agree with you. That's getting someone to connect with you on LinkedIn is not the same as developing a relationship with them and meeting them face to face.
Yeah.
So what is your friend, just out of curiosity, at NASA, what does he do as a plastics engineer?
I believe and I could be 100% wrong, I believe he works developing polymers for Mars missions.
Whoa, that's crazy.
Right? Yeah. So, and with the degree we have, we do the plastics engineering technology, which NASA technically does not hire. But the way you simply get around that is you get your master's and your PhD, and that's what he did. And he obviously is one of those guys that went towards more of the polymer side of things, and now he works at NASA.
Awesome. Okay, well, that's all I've got for today. Any last words before we wrap up?
I would just say again, don't underestimate the plastics industry. It's a great field and sorely overlooked, and it just provides more opportunities than people can really see at a glance.
Cool. And if somebody wants to reach out to you on Twitter, could you give us your handle?
Yep. So my Twitter handle is at LRCollard, and it's COLLARD.
Awesome. Thanks so much.
Yeah, no problem.
All right. Well, Lynzie, thank you again for joining us today and teaching us all about the plastics engineering career field. I really appreciate it.
Thanks for having me. I hope I inspired some people.
All right, I hope you enjoyed that chat with Lynzie Nebel. You can find the show notes for this episode, which will have links to the organizations and schools that we talked about, at STEMxm.com/episode 2. That's STEMxm.com/episode and then the number 2. Thanks to Lynzie's help with connections, we'll be hearing from some other plastics and materials engineers in the future that work in some different specialty areas from hers, so be on the lookout for those. For more info or to get in touch, head on over to STEMxm.com, and you can also reach out to us on Twitter. Our handle is STEMxm Podcast. If you'd like to help support the show, you can do so by visiting STEMxm.com/Amazon. And if you click through one of the links on that page for Amazon products, Audible, or Kindle books, and you make any purchase, we'll get a small commission from that. And that helps a lot to support the show. Thanks again for listening to the STEMxm podcast. Remember, whatever your dream is with a STEM career, you can accomplish it. We'll see you next time on episode 3.
This has been an episode of the STEMxm podcast. Thank you for listening. We would really love if you could pop over to iTunes and give us an honest, positive rating. It helps more listeners find us to learn about STEM careers. Thanks again, cheers, and we'll catch you on the next episode.